Hello everybody. So today I want to show you how to minimize the cost. We know that the company they have two buildings. The first building they will locate it on the other side of the river, and we know that this river that is about 1500 meters. That is about this one. And we know that the second building located on the opposite side of the river, and the distance from here to here that is about 5500 meters. The question, they want to set up the cable to connect building A to building B, but we need to know that the cable under the water they cost more than 2 times than the cable on the route. So let's say we have this building A. We put one cable on the under the water in here, and then in this cable they connect to building B. So here is the color I will highlight. Then from here we connect to building B. The question, they want to minimize the cost of this one. So in this case I will set up the first thing. We know that from this point here to this point here, I need to use the yellow color. So in this one we can see that this is about 1500, and from this point here to this point here I will put about S. So from this point to this point here, we know that this is about 5500, and we have the distance in here. That is about 5500. We need to minus about S in here. So the price to set up under the water that is 2 times on the route. So let's say I will have about A. So that means sorry, this one 2A. So the price in here that is about A. So let's say A, that is the price for the cable on the route. This is about 2A. That's about the cable under the water in here. Now we need to find the red color in here. So we can see that this is about the right triangle. We can use about Pythagorean theorem. To find the length of the cable under the water in here. So that should be about S square plus 1500 square. And this one I will put about Y. So this is about Y square. So we put the square root for the both sides, and we have like this. Now we need to find the total cost. So we have 8 multiply this one. That is about the total cost of the cable on the route. And 2A multiplied by Y. Y that is about this one. That is about the total price of the cable under the water in here. Now we can see that we have 8 and 8. We put 8 go outside. So we just consider about this function in here. So if we do first the derivative f of s, this is about application of the derivative. So we can find the critical value. Later that we can find the minimum value of this one. So we need to do first the derivative f of s. This one you got number 0 because this is about the constant. This one we have number 1. This one, first the derivative of the square root, we have number 2 with the square root of s square plus 1500 square. This one that is about 2s. So number 2 and number 2 we cancel. So we can simplify. We have negative number 1 plus 2s over the square root of s square plus 1500 square. Now we put this one equals to number 0, so we can find the critical values. So I will put negative number 1 go to the right, and then the square root go to the right. So we have 2s equals to the square root of s square plus 1500 square. So we put the power number 2 for the both sides to cancel the square root. So I will put this one cone here. So for s square minus s square, we have 3s square. So we divide both sides by number 3. So because this is about the cable length, so the length that should be positive. So we need to select s equals to 1500 divided by the square root of number 3. So that means after we have this number in here, we can put 1500 over the square root of number 3. So the cable on this river should be set up at 4633.97. So from here to here, we need to set up this number in here. So later that we can got the minimum total cost in here. This is the end. Thank you for watching.